An exponential function is an equation of the form b, a number, which we call the base, to the power of x, which is our variable. So I want to start with looking at simple exponential functions, and I chose the example of y is equal to 2 to the x. If I want to graph this, I can make a table of values. And for my table, I could choose any numbers I'd like, maybe -3, -2, -1, 0, 1, 2, and 3. And we can compute these really easily because the function is relatively simple. So I don't know, I could start with any number, so maybe what about 0? If I put 0 into this function, what's the corresponding y value? Let's check that. If x is 0, that means you're putting 0 in the exponent of 2, and the output would be 1. Any non-zero number to the power of 0 is, in fact, 1. All right, what if we chose x is equal to 1? Well, what about that? You put 1 into the variable, which is the exponent, and 2 to the first power is 2. All right, no surprise there. What about, x is equal to 2 and x is equal to 3? Well, this would be 2 squared, which is 4, and this is 2 cubed, which is 8. So we get 4 and 8. But what about negative numbers? Like, what if you chose x is equal to -1 and you put that into the function? That would be 2 to the -1 power. A negative exponent means you take that value and put it into the denominator to the positive power. So the answer is a half. You could use a decimal. That would be 0.5. That's what I'll put in my table, 0.5. We do the others. If you have x is equal to -2, that's 2 to the -2 power, which means 1 over 2 to the positive 2 power. That's a fourth, and as a decimal, that's 0.25. And the last one, if you have x to the -3, x equals -3 is 2 to the -3rd power. That's 1 over 2 cubed, which is an eighth, and that's 0.125. So before plotting these points, just some observations. You start at 0, gives you a y value of 1, and as you move in the positive x direction, the numbers are doubling every single time. So you go to 2, to 4, to 8, they're getting larger. But as you go in the negative x direction, you're dividing by 2. So you go from 1 to a half, to a fourth, to an eighth. The numbers are getting smaller. They're always going to be positive, but they are bigger than 0. So I'll try to plot as many of these points as possible. But let's start with at 0, you get 1. At 1, you get 2. At 2, we got a value of 4. At 3, we have a value of 8. And this makes sense. If I look at these values and they double every time, the graph should be increasing faster and faster and faster. So you get something going through those points that looks like this. As you move in the negative x direction, at -1, it was a half. At -2, it was a quarter. It's starting to kind of vanish on me here, but if I went to -3, it'd be even closer to 0. So I'll stop here and just say, all right, the graph is going closer and closer to 0, and I'll just put this arrow to indicate that. So what does this mean about our function? What's the domain and what's the range? So the domain is all real numbers. You can put any number you want in place of x, and you get something back for y value. It's not appearing over here just because the values are getting really large. And you can use negative x values. The graph gets closer and closer to 0, but I couldn't really sketch that very well, so I sort of just stopped it here. You can put any number you want in place of x. But what about the range? What are the corresponding y values of this graph? Well, you can't ever equal 0, but you can have a positive number, and all the y values can go from there up to positive infinity. So the range of this function is everything from 0, but not including it, up to positive infinity. So that must mean this line, y is equal to 0, is a horizontal asymptote. So this graph starts leveling off as it gets really close to 0, going towards negative infinity. So I'll write that down too. We get y equals 0. So that's pretty much everything you need to know about this graph. here I'm noting that the base was 2. If that happens, that means your graph is going to increase rapidly as you go in this direction and get really close to 0 as you go in the other direction. If you want to verify all this work in your graphing calculator, that's a very easy thing to do. In place of y1, you can put 2. There's a caret symbol towards the right side of your calculator, and then you place your variable x. So I encourage you to do that. Graph this thing in place of y1. The thing you should see on your screen looks like this. Then you should go to your table and just check to see that these values in fact match up, and they will. So that is it for this example, but let's look at a different scenario where I'll choose a different number for the base and see how that will affect the graph. All right, so what about this one? Y is equal to 1/2 to the power of x. I'm going to note that here the base is equal to 1/2. So that's not a number that's bigger than 1. In fact, the other case is going to be numbers between 0 and 1, like 0.5. If you'd like to enter this into your graphing calculator, there's 2 ways to do it. You could say let y1 equal, you'd need parentheses, 1 divided by 2 to the power of x. You could enter it like that. Or you could simply just change the 1/2 to a decimal, which is 0.5, and put that to the power of x. So that's what I'm going to do for this problem. I'm not going to use a table of values. I have my graphing calculator. I'm going to enter this in place of y1 and see how the graph looks different than the one in example 1. All right, so I just did that. This time, the graph didn't start down here and go up this way. In fact, it's kind of the opposite, where I see it drop down like this and then get smaller as we go in this direction. So I'm going to go right to my table and just get some values to see what's going on here. I think I could still use the same ones from last time, -3, -2, -1, 0, 1, 2, and 3. And since all these are already in here, I'll just double check this. Yeah, I get at -3, it's 8 instead of 1/8. At -2, it's 4 instead of 1/4. At -1, it's 2. It then gives me 1. Then it's 0.5, 0.25, and then 1.25. So this graph is just going in the opposite direction as the previous one. So let's see here. If I plot these points, just to get this up on the graph, okay, at -3, it's equal to 8. At -2, it's equal to 4. -1, it's equal to 2. At 1, it's 0. Then it's 0.5, 0.25, and it kind of disappears because I'm zoomed out too much. So I'll just draw the graph going between these points. Goes up like this, drops down like this, eventually kind of vanishes. So I'll just put this arrow to indicate that this trend continues. So in terms of the domain and the range, the domain is still all real numbers. No issues there. You can put any number you want in place of x and get a value back. The range is the same. Still everything from 0 to positive infinity. And y equals 0 again is a horizontal asymptote. So what's the reason for this difference? Let's see what we have here. I'm going to just pick a value at random. I'm going to choose, I don't know, what about here, 2. If I put 2 into this function, why does it give me 1/4? So the one that I am going to use is going to be 1/2 to the power of 2. Well, this is 1/2 times 1/2, which is 1/4, which is 0.25. So that's actually not very surprising. So here, since it's a 1/2, this 2 is squaring the denominator. So you still have a 1 on the top. Now the 4 is on the bottom. So you're dividing by 4 instead of multiplying by 4. So it went to 1/4 instead of 4. Well, what if I chose -2? What's going on there? If you put -2 into this function, so you're raising the numerator to the -2 power, but any 1 to any power is just going to be 1. And here that -2 is applied to the number in the denominator. But this means 1 divided by 1/4. Which means you're actually multiplying by 4. So the deal is, if you have a fraction, but you put a negative number in the exponent, it takes this and flips it back up to the numerator. the takeaway here is if you have a base that's between 0 and 1, the difference is the graph is going to decrease. Whereas if the base was bigger than 1, the graph is going to increase. So you can observe this completely by graphing this in your calculator, but it's something to point out that there's two cases to consider. Here we have a base between 0 and 1, the graph decreases. In the previous example, the base was bigger than 1, so the graph increased.